Okay, so in this lesson, we're going to continue talking about adding and subtracting radicals. And this is just a continuation of adding and subtracting radicals. Previously, you looked at adding and subtracting radicals that were square roots. And so in this lesson, we're going to look at square roots and cube roots as well. So we're going to look at those two situations. Most of our problems, if not almost all of them, will involve variables. So keep that in mind. Now, remember, when adding and subtracting radicals, you must be looking at like terms. So remember, you can only combine like terms. So keep that in mind. Okay. So let's kind of review something that you may have had from a previous lesson. So this is number one. You have the cube root of 8 plus the cube root of 72, and then minus 5. And the directions in all of these will say something to the effect either add or subtract. Um, it may say perform the indicated operations, but we're going to assume also that all variables will represent positive real numbers. All variables represent positive real numbers. So that way we don't have to worry about absolute value in our answer. All variables represents positive real numbers. All right. Now, in number one, there are no variables, but you will have variables in many of the problems. Okay, so first thing you got to do, if you notice that right off the bat, none of these terms are like terms. This is 8, this is 72, the radicand, and this right here is just a constant. That's not even a cube root, or it's not even written as a cube root, but it's just written as a constant. Okay, so you have to make sure that you simplify all radicals first. All right, so let's talk about the cube root of 8. So we know that 8 is a perfect cube, and we know that the cube root of 8 is 2. So right off the bat, I know that this is 2, right off the bat, because 2 times 2 times 2 is 8. Now, 72 is not a perfect cube, but we got to think about, well, what perfect cube goes into 8 evenly? And let's use the largest perfect cube. All right, well, I know that 8 is a perfect cube, so let's see if 72 is divisible by 8. So you just say 72 divided by 8, press equal, and it's 9. And notice the only perfect cube that goes into 9 is 1. So 8 is the largest perfect cube. Now remember how we did this. So I'm going to go off to the side. I'm just going to do that here. So remember, we got to simplify the cube root of 72. So remember the cube root of 72. So remember we used the product property for radicals. So that will be the cube root of 8 times the cube root of 9. Okay. Now we know the cube root of 8 is 2, so I get 2 cube root of 9. So that is as far as this can be simplified. So I'm going to rewrite this using this. So that's going to be plus 2 cube root of 9, and then that's just minus 5. And now notice the only like terms are these constants. 2 and a negative 5 is a negative 3. So I get negative 3 plus 2 cube root of 9. And so there's the answer there. Okay. All right. Number 2. And number 2, let's suppose we had 7 times the cube root of, let's say, a plus the cube root of 8a. All right. Now notice that remember when we talked about simplifying radical expressions with variables in the radicand. Remember, this is a to the first. Now since 1 is less than 3, then I cannot simplify this any further, okay, in terms of the variable. Now over here, we got to think about what this is. So let's talk about this for a moment. So remember, so we're looking at this one here, the cube root of 8a. So remember the cube root of 8a, I can write, just like I did this one, I can write as a cube root of 8 times the cube root of a using the product property for radicals. And so the cube root of 8, just like this, that was 2. And so I get the 2 cube root of a. And so that goes goes here. So this is 7 cube root of a plus, and then 2 cube root of a plus 2 cube root of a. All right, and so notice now those are like terms because this has a cube root of a, this has a cube root of a, so the radicands are the same. They're both a's. The indices are the same. They're both 3's, and so 7 plus 2 is 9. So you get 9 cube root of a. Okay? All right, so that was the work. Well, you could have done that in your head, but this right here, if it says show work, this would be your work right here. This would be the work, and this would be your answer. Okay, so keep that in mind. So this is this right here is the work, and then this right here would be the answer. All right. So on the worksheet, it will say, in some situation, we'll say show work. So make sure you know that going from here to here is the work I would need. Don't go from here to the answer. You're not going to get all your points. All right. Number 3. So let's number 3. Number 3, let's suppose we had negative 17 square root of 8m plus 5 square root of 18m. Okay? So we got to simplify the radicals. So right away you can tell that these are not like terms just by the way they look. See, that's 8m, that's 18m. But maybe we can simplify the radicals, and then I could determine, hey, those are like terms. Because remember, before you can combine like terms, make sure that those radicals are simplified. All right, so let's talk about the square root of 8m. So let's do that, square root of 8m. So the square root of 8m, using the product rule, is the square root of 8 times the square root of m. I cannot simplify m any further because the exponent of m is 1 and 1 is less than 2. But I can simplify the square root of 8 because a perfect square, the largest that goes into 8 is 4. So this becomes the square root of 4 times the square root of 2 times the square root of m. And the square root of 4 is 2. And then notice the product rule. Also, when you multiply two radicals and the indices are the same, you can multiply the radicands together. So this becomes the square root of 2m. So the square root of 8m is this. Okay, so that becomes right here. So that becomes negative 17, and then this right here is this. So be careful. So it's 2 square root of 2m plus, and then 5 times, and let's talk about the square root of 18m. So the square root of 18m. So the square root of 18m, would be the square root of 18 times the square root of m. The square root of m I cannot simplify because 1's less than 2, but 18, the square root of 18 I can simplify because the largest perfect square that goes into 18 is 9. So I can write this as the square root of 9 times the square root of 2 times the square root of m. And the square root of 9 is 3. And just like we talked a while ago, since the indices are the same and so these are the same, and multiplying those together, I can multiply the radicands. So this becomes the square root of 2m. So this is this. So that means that this right here, which would be multiplied by 5, is this right here. So 3 square root of 2m. And then I get negative 17 times 2 is a negative 34 square root of 2m, plus 5 times 3 is 15 square root of 2m. All right, so here's your work. Okay, that's your work. And then now those are like terms, and so I just add these together. So a negative 34 plus 15 square root of 2m's gives me a negative 19 square root of 2m. Okay, all right, so that's number 3. All right, let's look at number 4. So this is number 4. So number 4, let's suppose we had this in number 4. All right, number 4, we have the square root of 25x plus the square root of 49x cubed plus 4 square root of x, and then minus 2x square root of x. Okay, So let's notice I have 1, 2, 3, 4. I have 4 terms. So let's go ahead and simplify each of those terms first, and then notice that this I cannot simplify any further, nor can I simplify this one. But these I can. These two I can. And then let's see if I can combine any like terms. So let's talk about the square root of 25x. So I know that the square root of 25x, according to the product rule for radicals, I can write this square root of 25 times the square root of x. 25 is a perfect square, so that becomes 5 square root of x, right? So that is this. So right off the bat, I know this. That is 5 square root of x, okay? Plus, now let's talk about this one. Okay, so over here, I have the square root of 49x cubed. And so according to the product property for radicals, I can write this as square root of 49 times the square root of x cubed. Now 49, that's easy because that's a perfect square, and the square root of 49 is 7. But remember right here we said we couldn't simplify this because 1's less than 2. I can simplify this because the exponent is greater than or equal to the index. Now remember how we did this. So we said there's going to be 7. And I can write the square root of x cubed as the square root of x squared times the square root of x. Because remember, when you multiply like bases, you add exponents. So remember what we did. We found the largest whole number, less than 3, that's divisible by 2, and that's 2. And now we know this. We know that this is 7. The square root of x squared is x, because x times x is x squared, times the square root of x. So that right here is this. Okay, so I'm going to replace this in the problem with this. So that's this, 7x square root of x. Now I cannot simplify this any further, so I'm going to rewrite it. And I cannot simplify this any further, so I'm going to rewrite it. So the only two I could simplify are these two. Now let's see if any are like terms. So I have a square root of x here. I have a square root of x here. Now don't say, now be careful, remember these are not like terms that I'm pointing to. Those are not like terms, because even though they all have square root of x, this has an extra factor of x and this does not. You see that? Okay, so we talked about that in a previous lesson. So the like term with this one is this one right here. So 5 square root of x plus 4 square root of x is 9 square root of x. And now these are like terms because they both have square root of x and they both have an extra factor of x. So 7x square root of x minus 2x square root of x gives us, these two are like terms, gives us 5x square root of x. All right, and if you want to rewrite the answer using this term first, you can. 5x square root of x plus 9 square root of x. Okay, it does not matter. All right, number 5. So in number 5, we have this. We have 4 cube root of 8x cubed minus 7 cube root of 32x cubed. Okay? All right. So let's go ahead and simplify each of these. So let me go ahead and put this right here. Okay, so let's simplify this one. So this right here is the cube root of 8x cubed, right? All right, so I can rewrite this as the cube root of 8 times the cube root of x cubed. And the cube root of 8 is 2. Now this is easy because 3 is divisible by 3, so the cube root of x cubed is x. So that's just 2x right here. So this is 2x. So I'm going to replace this with 4 times 2x, because that's what we found this to be. Now let's talk about this. So it'll be minus 7 times whatever this is. So over here, this becomes the cube root of 32 x cubed, right? And so according to the product rule, I can rewrite this as the cube root of 32 times the cube root of x cubed. Now 32 is not a perfect cube, but there is a perfect cube that goes into 32, and that's 8. So I can write this as the cube root of 8. Remember, 8 times 4 times the cube root of 4. And this is just x. So this right here becomes 2. The cube root of 8 is 2. Cube root of 4 times x. And I'm going to rewrite this where I put the cube root at the end. So I'm going to write this as 2x cube root of 4. So that is this. So this right here becomes 7 times 2x cube root of 4. Okay? And now, so this becomes 4 times 2x is 8x, minus 7 times 2 is 14x cube root of 4. Now, here's the thing. These are not like terms, so you can't do anything else to it. So you're done. And the reason they're not like terms, because, see, if this is what you had, then those would be like terms. 8x minus 14x is, you can write as one term, is negative 6x. But the fact you have that cube root in there, those are not like terms. So that's all you can do. So there'll be situations where you can simplify, but you can't go any further. You're done. Here, you simplified and you were able to combine like terms. Here, those are not like terms, so you're done. Now that's the work right here. This is your work, and that's your answer. Okay, this is your work, and this is the answer. All right. Okay, number 6. All right, so I'm going to go ahead and put this here, right here. All right, so let's look at number 6. So number 6, we have this. Okay, number 6. All right, we have negative 8 cube root of x to the 7th minus x squared cube root of 64x. Okay? All right, so let's simplify these, and then hopefully we can combine like terms. So let's talk about this one here, this radical. So that's the cube root of x to the 7th. Now, you've dealt with this in previous worksheets and previous lessons. So I'm going to have to rewrite this to use a number that's divisible by 3. So I can write this as the cube root of x to the 6 times the cube root of x. And then 6 divided by 3 is 2, so that's be x squared. Kind of makes sense because x squared times x squared times x squared is x to the 6. I cannot simplify this any further because 1's less than 3. So this is what you get. So this right here is this. So I'm going to replace this with negative 8 x squared cube root of x. Okay? All right, now let's talk about this one. So minus x squared times, all right, so this right here, we got to simplify this now. So that is the cube root of 64x. So I'm going to rewrite this as the cube root of 64 times the cube root of x. Now the cube root of 64, is 64 a perfect square? Well, let's see, the cube root, so just do this, just you have access to calculators, so you want to do cube root, so cube root 64 equals 4, right? So you get 4. So that'll be 4 cube root of x. So remember, you have access to calculators, so if you're not sure, use your calculator. So that's this right here, right? So that's this. So I'm going to replace this with this now. This becomes this. So I get minus x times 4 cube root of x. Now I'm going to go ahead and rewrite this so that that number is in front like this one is. So I get negative 8 x squared cube root of x minus 4 x squared cube root of x. And now notice those are like terms because they both have cube root of x's and they have the same extra factors of x squared. So a negative 8 and a negative 4 gives me a negative 12 x squared cube root of x. Okay, so there's the work, and there's your answer. All right. Okay, let's look at number 7. So number 7, we have 9 times the cube root of 108 x to the 8th power plus x cubed times 32 x to the 5th. Okay, so 9 times the cube root of 108 x to the 8th plus x cubed times 32x to the 5th. All right, so we got to simplify each first, and then hopefully we can combine like terms. So let's talk about the cube root of 108x to the 8th. So the cube root of 108 x to the 8th. So according to our product rule for radicals, I can write this as the cube root of 108 times the cube root of x to the 8th. Now let's talk about the cube root of 108. So let's determine if there is a perfect cubed that goes into 8 besides the number 1. So let's see. Let's try. The next perfect cube after 1 is 8. So let's just try 8. 108 divided by 8. Let's see if that's going to be a whole number. All right, and it's not. All right, so let's try the next one. 27, right? 3 cubed 27. So let's try 27. Oops, sorry. 108 divided by 27. And you get 4. So it's 4. So 27 times 4 is 108. And the only perfect cube that goes in 8 is 1. So that means that 27 is the largest. So this becomes the cube root of 27 times the cube root of 4. And let's go ahead and rewrite this. So remember, 8's not divisible by 3. So you want to find the largest whole number less than 8 that's divisible by 3, and that's 6. So it'll be the cube root of x to the 6, and then cube root of x squared. Because when you multiply like base, you add exponents. 6 plus 2 is 8. All right, now I can simplify this right here. This is 3, right? Times the cube root of 4. This cube root of x to the 6 is x squared. And I cannot simplify the cube root of x squared because 2 is less than, the exponent is less than the index. All right. Now, you don't want to write it like this because you remember, you know that when you're multiplying radicals and the indices are the same, then you can write it as one radical. So this becomes 3x squared times the cube root of 4x squared. 4x squared. So that is this. Okay? So that right here is this. So it becomes 9 times the, so it becomes 9 times 3, that's times 3, x squared, cube root of 4x squared. All right? So notice all this stuff you learned in the past right here. So there's nothing new to this. That was lessons you've learned, worksheets you practice with. This is just a new one, just where you simplify each one, then you see if you can combine like terms. Let's talk about this one, 32. So this is 32, the square root, I'm sorry. I think this was supposed to be cube root right here. Cube root of 32x to the 5th. So this is plus x cube root of 32x to the 5th. All right, so we get cube root of 32x to the 5th. All right, so we're going to rewrite this as the cube root of 32 times the cube root of x to the 5th, right? Okay, so 8 again is the largest perfect cube that goes into 32. So it'll be the cube root of 8 times the cube root of 4. And then just like we did this one, the largest whole number less than 5 that's divisible by 3 is 3. So it becomes the cube root of x cubed times the cube root of x squared. So this right here is this. 3 plus 2 is 5. Simplifying this becomes 2. Cube root of 8 is 2. Cube root of 4. The cube root of x cubed is x, because x times x times x is x cubed. I cannot simplify this any further because 2 is less than 3. But I can rewrite this as 2x times the cube root of 4x squared. So that is this. Okay, but notice what you've learned in the past. Remember, this is in the past. That's not new. All right, so that, I'm going to rewrite, I'm going to put this right here in place of this. So it becomes plus x times, and then plus x times this right here. So 2x times the cube root of 4x squared. Okay, let's simplify this now. 9 times 3 is 27. So I get 27x squared cube root of 4x squared plus x times 2x is 2x squared times the cube root of 4x squared. Now I want you to notice, and this is important, these are the same. So I have 27 of these and I have 2 of these. So altogether I have 29. So those are like terms. So I have 29x squared times the cube root of 4x squared. And there's the answer. So that's your work right here, and that will be your answer. Okay? All right, so that was number 7. Let's do one more. Okay. So this is going to be number 8. So in number 8, we have this. In number 8, we have the cube root of 135 xy cubed plus y times the cube root of 625 times x. Okay? All right. So let's talk about simplifying each of those radicals, and then let's see if we can combine anything. Okay, so we have the cube root of 135 xy cubed. Okay, all right. So so let's rewrite this using our product rule for radicals. So it becomes a cube root of 135 times the cube root of x times the cube root of y cubed. Okay. All right, now let's talk about the cube root of 135. So use your calculator and see what perfect cube, if any, besides 1, will divide into 135. And so what I would do, since that's a 5 right here, and I know that 5 is not a perfect cube, but let's divide it by 5 and see if that's going to help us. So when I divide 135 by 5, I get 27, and 27 is a perfect cube. So 27 times 5 gives you 135, and there's your perfect cube right here. So I'm going to rewrite this as the cube root of 27 times the cube root of 5. Okay? And then the cube root of x I cannot simplify, so I'm going to rewrite it. The cube root of y cubed, 3 is divisible by 3, so that's just y. And then now I know that the cube root of 27 is 3, so I get 3 cube root of 5 cube root of x times y. And remember our discussions in previous lessons, I can write this as 1 cube root. So I'm going to put the 3y first. So I get 3y times the cube root of 5x. And remember, always put the radical expression at the end, especially that contains a variable in it. All right, so there's that right here is this. Okay, a little bit of work you had to do, but you know how to do this from previous lessons. So this is this. So I'm going to replace right here. I'm going to replace this with that. So that becomes 3y cube root of 5x plus y times, now let's talk about this. All right, so, and for that one, we have the cube root of 625x. Now, according to the product rule for radicals, I can rewrite this as the cube root of 625 times the cube root of x, right? Okay, so let's talk about 625. Now, 625 is not a perfect cube. You can even check that. So you would say 3 cube root of 625, and notice it's not a whole number. So it's not a perfect cube. But just like we did a while ago, let's divide that by 5 and see what we get. So 625 divided by 5 gives us this. And we know that this is a perfect cube. Because what's the cube root of 125? Well, 5, right? 5 times 5 times 5 is 125. All right, so I get this. I get the cube root of 125 times the cube root of 5 times the cube root of x. And again, I cannot simplify the cube root of x because the exponent of 1 is less than 3. So this right here becomes 5. Now remember, I can write this as 1 cube root, so you got to do that. So as the cube root of 5x. So that is this. So now I'm going to replace this right here with that. So it becomes times 5 cube root of 5x, and that's being multiplied by y. Okay? So now what we have is this. We have 3y cube root of 5x plus, I'm going to put the 5 first. So 5y times the cube root of 5x. And notice those are like terms, right? They both have the same cube root of 5x's. The indices are the same, the radicands are the same, and they also have that extra factor y. Both of those right here. So those are like terms. So 3 plus 5 of them gives me 8 of the 8y cube root of 5x. And there's your answer. And remember that, oops, sorry, this right here is your work. Okay? All right, so most of that is just remembering something from previous lessons and previous worksheets. But basically what you're doing here is you got to simplify each term, and most of the time you're able to. And then once you do that, if you can combine them, you combine them. If you can't combine them, then you leave that as your answer. All right, so that is, let's see, that was, let me get the word, so that is the lesson on adding and subtracting radicals.